But I'm very thankful to the organizers for giving me this opportunity to share my research experience. Okay. So I think I will come here. I will change my. Okay. So the title for the today talk is the fuel cell as the next generation renewable energy technology. So as this program is completely dedicated to hydrogen energy, so the use of hydrogen energy is a simple electrochemical device, and among them the hydrogen energy or fuel cell is a one of device. The fuel cell is a simple if you are because you also read about the electrochemical cells in your +2. And in +2 you already know about there is a 3 electrode systems: anode, cathode and electrolyte. So this fuel cell is the same as that, only the change is the type of fuel used in this cell. Okay, so today I will discuss about this fuel cell, followed by these are the outline, introduction. I will give you some exposure about what is the fuel cell, what is the renewable energy technology, why it is needed, followed by their history, classification of fuel cells, some literature review, because if you are working or you are start to work in this area, then you need to review some articles, review some work by the other authors in other country. So followed by the motivation. Always try to find your motivation, because if you are working in some area, so the motivation is the most important part. Without motivation you can't work. Okay. And then current research work, I will also show some of my research work which is carried out in fuel cells and references. So if you are talking about the background, so I will just yes. So if you are talking about the background, so energy is the foundation of socio-economic development. To promote modern civilization thrives on efficient energy system. It also rapid, because you all know that there is a rapid growth of industrialization. So they all need a technological growth, and also have driven an ever increasing global energy demand. The 21st century brings dual challenges: meeting energy needs while protecting the environment, because you know the fossil fuels are already covered all the areas. If you are in nowadays you are using the fossil fuels as a major source, and due to this fossil fuels there is a emission of carbon related gases which harms your environment as well as the social life of population. So that's why the people need some green and clean energy. So fuel cell is the device which produce green and clean energy, because the outcome of this fuel cell as the water, and water is the not a harmful product. And if you see, the fuel cell technology converts chemical energy directly into electricity, and it offering high efficiency with minimal emission. It is not even though correct that we were only working in this fuel cells. If you are trying to find some alternative energy sources, the one of the also class is the solar energy. But the major or the beauty of this fuel cell is that here you are getting the byproduct as a water. Okay, you all are comfortable now? Okay. And then if you see here, there are various kind of renewable energy sources: EDLC, lithium ion capacitor, lead acid battery, lithium metal hydride battery, lithium ion battery, and fuel cell. If you see here, there are two factors which generally control the energy of your or control the application of your device. That is the energy density and power density. If you are talking about the battery, because if the few of you is try to work on the battery has a good power density, but it has very low energy density. But if you are working on the fuel cell has a good energy density, even though it has a low power density. So if you try to work on fuel cells, so try to increase this power density for the fuel cell. This power density, energy density has only minimum the small difference, that the power density means how rapid you need power, and energy density how much energy you want to store. So these two parameters have a very small difference. One, how fast you need power, and the second, how much need of your energy. Okay, so the how much need of your energy is larger for fuel cell. You can produce electricity to give using the fuel cell to a village, a town, okay, but not from the battery. But from battery you need power rapidly. Even if you require, you just here if you have pointer, if pointer is not working, you just replace the battery and you can get the power in very short time. Okay, so that is the beauty why we choose the fuel cell, because fuel cell has the high energy density and we need to increase their power density term. If you're talking about there is a technological competition, so there are so many technologies available in the market: fuel cells, micro turbines, combustion turbines, reciprocating engines, Stirling engines, photovoltaic system. This is your solar energy, and last one is the wind system. That is the Pawan energy. Pawan Urja, you all know about the Pawan Urja. So if you see here, the fuel cell has the maximum of efficiency about a 60 to 85%, which is very much better than the other technologies. So that's why fuel cell has a great importance in nowadays. Okay, so if you're talking about the history of fuel cell, what is fuel cell? Fuel cell is a kind of energy conversion device, and it is based on the principle of electrochemistry, the principle of the primary battery. It converts the chemical energy stored in fuel and oxidized into electricity energy directly. So the actual process is a redox reaction. Okay, and the fuel cell comprises three parts: anode, cathode and electrolyte, similar as your battery. Okay, and if you see the history, so it come into the picture from 1839, and nowadays in 2008 Honda begins leasing the FCX Clarity fuel cell electric vehicles. So Honda has already started the fuel cell based vehicles. So this is a classification of fuel cell. Fuel cell, depending on the nature of electrolyte used in your fuel cell, the name of the fuel cell comes. Like if you are using the polymer electrolyte, then it comes under the polymer electrolyte membrane fuel cell, and their operating temperature is 70 to 110 degrees centigrade. If you are working on the alkaline fuel cell, if you are using the electrolyte as alkaline solution like sodium hydroxide and potassium hydroxide, so this is called as alkaline fuel cell, and their operating temperature is less than 110 degrees centigrade. If you are using the phosphoric acid fuel cell, where the phosphoric acid as the electrolyte, so this is phosphoric acid fuel cell, and their operating temperature is 150 to 200 degrees centigrade, and corresponding reaction, electrolyte reaction, is also here given. Okay, I will explain for the fuel cell in the upcoming slides. Here I am just giving a summary of your different class of fuel cell. And another one is the molten carbonate fuel cell. Here the potassium carbonate and lithium carbonate will be used as a electrolyte. And the last one, which I am working on, this solid oxide fuel cell. Here a solid material is used as a electrolyte. Okay, if you're talking about electrolyte is the major part of any device. If electrolyte is liquid, their performances may be good, but their stability is not good. So we are trying to replace those electrolyte in form of solid, because solid has a good stability. Okay, that's why we are choosing solid oxide fuel cell, and their operating temperature is above 500 to 1000 degrees centigrade. Because if you are producing the high amount of electricity, then it need a high amount of temperature. It generates high amount of thermal energy, and that much thermal energy is needs for those materials that are very much thermally stable. That's why oxide material is required here. Yes. Okay. So this is the working mechanism of the SOFC. So here I want to just explain what is the process. So this is your cathode, this is your anode, and from here I will insert the hydrogen as a fuel, hydrogen gas, and that gas will be here oxidized into H plus ions. Means H2 gas gives 2 H plus ions, and electron will be generated, and this electron is flow through the circuit where you require an electricity, and this electron is captured by this oxygen which is coming from this anode, and this oxygen, if oxygen gets electron, what will happen? This will reduce their valency to O2 minus, and if you combine these two reactions, then what will happen? This H2 plus A2 and this 2H plus and O2 minus combine together and form the H2O. This is the byproduct which is coming from this tail of the cell. Okay, so this is the basic principle of fuel cell, and this principle is applied to all other type of fuel cells. Okay, maybe their byproduct will be changed depending on the chemical reaction between the fuel. Okay, so now if we come forward, so what is the properties of solid electrolyte? The following properties for the electrolyte matter should be. Now we need to focus, because the electrolyte has this property. Okay, the electrolyte matter should be higher degree of oxide ion or proton conductivity. Proton conductivity required for the proton exchange membrane fuel cell, and for working on the SOFC, they require the oxide ion conductivity. Okay, and that conductivity should be in order of 0.01 to 0.1 Simon per centimeter, and the material thickness should be 1 to 100 micrometer. We can't place very much larger or very thick material, but we need to prepare a material which has this much of thickness of electrolyte, should possess this much amount of conductivity. Okay, and that conductivity is assigned to oxide ion conductivity. If we why oxide ion conductivity required? Because here you see, here if oxygen is just captured the electron and it produce